have a little more complex questions. A mole is the one thing in chemistry that allows us to compare. So a mole is that center point. We know that it's equal to 22.4 liters of a gas. That's ideal at standard temperature pressure. We also know it's equal to 6.02 times 10 to the 23rd particles. That number doesn't change. And we also know that it's equal to the molar mass of a substance. This is the one number that's never certain, like these two values are always the same. This one changes based off the substance that it is. So the problem we're given this time is how many grams are in 8.140 times 10 to the 25th formula units. Remember, fancy word for compound of sodium sulfate. So the first thing I look at is I recognize that this is a particle. So I'm going to start off knowing that I'm using 6.02 times 10 to the 23rd particles. So this is my quantity. I'm going to start off with 8.14 times 10 to the 25th formula units. Do not write FU. It's FUNS. Thank you. And I know that for every 1 mole of a formula unit, I have 6.02 times 10 to the 23rd. Now, if you feel more comfortable, you could write 1 mole here, but I also know these are all equivalent. My goal is to get to grams. Well, I know for every mole, I have a certain amount of grams based off the periodic table. I'm going to put that here. You can do 2 steps, or you could do 1. Now, let's see. Sodium, every sodium, let's use that beautiful periodic. Every sodium is 23 grams. Let's see, that's 46. And I have sulfur. Sulfur is 32. I only got 1 of them. And I've got 3 oxygens, which is 16. That's 48. Add those together. 8 plus 8 is 16. 5, 8. Woo, the mental math for the morning. So for every 1 mole, or for every 6.2 times 10 to the 23rd particles, I have 126 grams. Now that I have my equation set up, I can just calculate. So I'm going to use my trusty calculator. I have 8.14. Doesn't allow me to do exponents. So I'm going to take the exponents out and worry about them later. Times 126. Let's see, denominator, so divided by 6.02. And I'm left with 1703729. 25, 23, so I subtract, since it's divided by, it leaves me with 2, so that's 10 to the 2nd power. If I look back at the beginning, I have 4 significant figures. So I'm going to add this one point there. I need to stop after the 3. 7 is 5 or more, so I'm going to round this up, which leads my number to 170.4 times 10 to the 2nd, and that would be grams. Now, I can't leave it, since if I'm going to do scientific notation, this has to be 1 point, or I can multiply that through. Either way, I think change this to sig figs a little easier. 1.704, I took out 100, and it's times 100. So just add those 2 together. 2 plus 2 is, I don't hear you, 4. Thank you. So we're left with 1.704 times 10 to the 4th grams. That would be your answer. So moles, you can put them in and then have a second relationship here with 126 grams per mole, or do it in 1 step. That is totally up to you. This is how a mole works. A mole allows us to start comparing all of these different measurements. Stay safe.